Welcome everyone to this bonus update. As I mentioned in the previous live streams, I wanted to finally finish some more details on the Voodoo previously in our low-level code here on DOS. By the way, you can already power this on. From some frame drop. Why do we only get frame drop when we start going live? It's hilarious. Does this version a little bit? Nah. So let's hope that reduced bandwidth. So let's start this. This is a new setup with the transmitter, well, the very unlikely setup of the thin client there with the Voodoo onto it. Oh, I can also manual focus because amazing camera setup. So yeah, totally normal setup there, nothing to see or something like that. And yeah, just from the previous live streams, what is so outstanding with that is that we network boot that I probably could have switched to sooner. And yeah, NetDOS, not faking this, the new setup from the previous live streams. The nice thing is no open test bench, dusty vintage board here that can short something. Well, so far didn't happen, but also nicer for the office when we continue working here tomorrow, then the desk is less full with vintage gear. And also added compile cycle, of course with the NetDOS MTCP DOS network stack, allowing us here very nice compiling GCC on Linux, and then here object dir and /update. And what is new, so I have not the pass-through cable, so old-fashioned integrated graphic output there and Voodoo here. And so last time a month ago or so, we left off with having that low-level infrastructure glue, copy and paste it together code working. Also the Voodoo 2 has 2D acceleration, so we had that working right into the frame buffer and 2D block transfer and maybe fill, rectangle fill, and I couldn't get triangles to work. It's like, yeah, okay, not important, works, proof of concept, good enough, but another day I do triangles, and the other day was today, so okay, can't switch yet to that because no video output, so run there, switch there, and now we finally have their triangle. So that is new, took me here a couple of hours, and it was only like maybe 1 bit. This triangles here, so we write here this test pattern, we write into the frame buffer, we then bit BLT here this frame buffer from here to there, and then 2D accelerate here this rectangle fill, and then new today, a couple of hours trial and error. Also, I show you in a second what was the issue. Also here's some debug output, actually not too bad here for this setup in terms of dual head. I mean, this is of course 1996 dual head, right? Theoretically, if you had the luxury of 2 displays. So I used this here, this is the mode computation there, and then this is new from today, not only, so this is some floating point. Also, this is all our own C library, right? So some poor man's floating point output. Actually, my poor man's floating point stuff can only output 1 digit there in this maximum 64K COM executable. So, and this is pixels. This is pixels in and out is from the, I think, FBI or whatever, from the Voodoo 2. The pixels it's generating, it's clipping, and so this in is input into the FBI frame buffer interface or whatever that was, input and output, and this can differ in regards to clipping and chroma key and stuff like this. So yeah, of course, not that much to see. But as I said in the other stream, it is either 90% takes 10% of the time, and this is the same for creating new high-level stuff, web databases, or this kind of stuff. 90% is the enablement here, and yeah, like looking here through all the registers, and once you have code that sets the stuff up and starts to work, then the remaining texturing and amazing stuff is then only 10%, so kind of the 90% mark we have passed here. And welcome to Xutku. And also here, multi-display, so hello, can we switch here? So yeah, the bit actually, before everyone tunes out, I made here some notes actually. So I said already a couple of times, I previously never had this and only realized with this YouTube videos that people love it so much, the accelerator. I had the S3 Virge deaccelerator. I made a couple of notes, so I was surprised because I actually prepared also texturing. Of course, next is texturing, the famous Lena that we also have for the S3 Virge. And to my surprise, I already changed some defines for next, of course, texturing. And I was surprised to find that the Voodoo cannot do 24 or 32-bit RGB, like full 8-bit RGB, because even for the S3 Virge, for the super tiny 64K DOS demo example, my texture actually was 24-bit, 8-bit RGB. That the Virge, of course, can even do. And of course, this is a huge controversy that the Voodoo only had 16-bit frame buffer and always used dithering and so on. And yeah, anyway, I am surprised that it can't use this 8-bit RGB as input source, because due to that, my super tiny small code I had to change to convert this here on the. I'm not using this yet, right? I'm literally 10 minutes ago. Finally, the triangles worked. So yeah, this is so much to the S3 Virge is a deaccelerator. At least it can be not only do 8-bit RGB, 24, 32-bit frame buffer. It can also use RGB, RGB alpha, 8-bit, 32-bit, 8-bit per component as texture format. So something that the Voodoo, yeah, it is slower, but it can do higher quality. So other benefits, the S3 benefits, additional are also, what have I even written there? Yeah, higher resolution. So the S3 Virge can do up to, I think, 1600 by 1200. And back in the day, I think I had the no-name like Vobis or something, 17-inch CRT later, of course. And I think it could even do 1600 by 1200. Maybe only interlaced or whatever. Of course, the S3 Virge with the limited memory at the time only could do this 8-bit palette color, but for professional computer-aided design that probably was usable. Then the S3 Virge, you could do 3D in a window. The Voodoo always operates full screen, so there is nothing, I think, I found, at least in the Voodoo 1 and Voodoo 2, it has this path-through thing anyway, so you could not really do window 3D. Very theoretically, you could have on the S3 Virge multiple 3D applications. Of course, yes, performance deaccelerator, but you could have one cat thing doing some wireframe in one window and some other stuff. For example, in a game development situation, you could have your wireframe in one window and your textured test data in another, for example. Very hard, if not kind of impossible. Well, unless you use a dual head, one display in the Voodoo, but yeah. Anyway, windowed is possible. Right, and then the S3 Virge can do lines, 3D lines for wireframes, for computer-aided design. The Voodoo, I think, cannot do lines. At least I've not seen it. And of course, the S3 Virge can do 2D. So quite some benefits on the S3 side, except it's slower. The Voodoo, the biggest benefit of the S3 3DFX Voodoo is performance. Like the biggest, only most performance. Yes, it can spit out textured triangles at an amazing for its time, but yeah, it also has quite some circuits there, quite some integrated circuits, and it is getting quite warm actually. Do we have? So yeah. Of course, it's much more complex, many more integrated circuits and dedicated, I think, dual memory channel for, I think, frame buffer is connected separately from the textures. One of the tricks probably that they got such high performance back in the day. Yeah, so performance, what have I even written there? So also fast clear. So one thing that I need to implement next is fast clearing the frame buffer and devs buffer, the set buffer. The Virge, in this S3 Virge, I have not found anything. I did a little bit of a hack to do this hardware isolated. I misuse the triangle drawing a little bit with a little bit outside conditions there. So I'm basically using the triangle engine not to draw a triangle, but a rectangle. Not really sure if it was meant that way, but at least it worked on the Virge. But anyway, pros and cons. But you could do isolate something, but yeah, the Voodoo has dedicated fast clear of frame buffer and set buffer, and damn, I really need to write more clearly. Anyway, yeah, right. Floating point. So at least the Voodoo 2 can do. Not sure if the Voodoo 1 can do this, but the Voodoo 2 has floating point, so your coordinates of your triangles you can write directly in floating point registers. The Virge cannot do this. The Virge always accepts the same fixed point integer coordinates. Not really sure. Probably in games you probably always would use integer coordinates anyway. But the Voodoo, theoretically, you could do floating point writes to the registers, which, by the way, I use just for testing to make my life easier. Maybe the Voodoo, at least the Voodoo 1 has integer and maybe floating point, not sure. The Voodoo 2 has the floating point and additionally triangle setup. Triangle setup meaning that you do not need to compute. Did not restart the window manager. The window manager does it have here somewhere is some, but anyway, here maybe, no. You can watch the previous video. What do you mean with memory? The Voodoo can do the triangle setup, which is you normally for the Virge and the Voodoo, otherwise the Voodoo 1, you need to compute all the delta parameters for the movement of the rasterization engine and also clipping. I have not tested this, but at least with the setup engine that, again, I have not yet tested, but at least you do not need to compute all the delta values for the edge walking algorithm there in the card. And maybe, I'm not sure, I will test this another day, I would hope that it also do clipping. So if you draw a huge triangle on the Virge, you might have, so not only do you need to clip this, because the Virge can only have starting coordinates that are in the visible buffer. If you use coordinates so they cannot be negative, if the triangle on the Virge would start here, you would need already to pre-clip the, actually can also zoom this, you would need to pre-clip the vertex coordinates to a visible coordinate, so it cannot be negative. So this also means that I think there are boundary conditions where you would need, if you have a triangle that starts outside of your visible screen, and I think there are conditions where would need to draw this and solve this algorithmically. Okay, it's late. I think there are conditions that you need to even generate two triangles, otherwise if they are starting so that maybe theoretically. Anyway, would need to check this another day. So the only bit, in a similar theme to the most expensive scanner that we reverse engineered, there were some error bits take a whole afternoon to just find where the error bit is. Today, I moved the browser again. We should have started, which is even Firefox. What have I done with the browser now? Come on, Voodoo specification here. So that it would have already worked last month if it would not have been for one bit, and the one bit is here RGB buffer, because so this is a FP set mode register, and I said this before, the Virge and the Voodoo are quite similar in terms of these registers here. You write the vertex coordinates in there, or you need to sort them, right? The Virge and the Voodoo need them sorted. Fun fact, the Virge needs to have them sorted Y coordinate decreasing. So from bottom to top, the Virge, you can watch the videos, I will keep this short. You can watch the previous videos if you're interested. So the Verge always draws bottom up and the Voodoo always draws top down, interestingly. And so this the register is quite similar. So you have similar vertex registers and delta registers. This is like so entirely different. This is really this is so much similar that it's really interesting that the companies, maybe they had employees from SGI and such, changing companies, that concepts are quite similar. And of course, when you start, initially you write to most of the registers, you write 0 because you don't want to use most of the stuff until you have stuff working and you need some, like, for example, texturing, your triangles. Of course, you disable clipping because I don't need clipping right now. So the more stuff you enable, the more stuff you need to set up correctly, and unless you really need it and you programmed everything, for example, clipping, yeah, I don't need it. Clipping is like if you have a real game and you really need to clip it. So to make stuff simple, usually I start with most stuff disabled, no clipping, certainly no chroma keying. Chroma key meaning comparing with a color, some chroma color, like some green, like only drawing into areas that are green, some green screening or whatever. Floating point depth buffer, yeah, so whether the depth buffer is floating point or integer, whether even to enable depth buffering, the set buffer for the depths. Of course, we want to draw this stuff, like don't care, just draw all the pixels. So most of the stuff is disabled, and enable this ring, RGB buffer, depth alpha buffer, enable alpha channel mask, and so on. Like you see, basically, we don't want any of this. The only thing I overlooked is RGB buffer right mask, and this bit is the only bit took me like 2 or 3 hours to find today, because normally you debug, you think your coordinates are off, some other whatever, so you go through the specification, you compare each register, like could it be this bit, could it be that bit, is the color, do I write to the correct color register, do I write to the correct command register, to the because as I said, it has integer and floating point, and then you start to wonder, do I even write to the correct register matching the command register, because it has here, these are the registers, they are pretty similar to the Verge. And then you, I can resume. And then it could be that you write to, the Voodoo has the X, Y, Z register sets 3 times for integer, floating point, and setup engine. And it could also be that I write to the wrong registers there and all this fun stuff. So yeah, it takes then 1 hour trial and error, another hour trial and error, and then eventually, oh, there is this RGB mask thing. So what is that doing? Let's look this up again. So yeah, this is also documenting to show you all the steps. You always think, yeah, you write this in one afternoon. It has a reason why the X drivers matured over the years, and it's so set that they delete this. Here it's, by the way, our RGB mask apply visibility. Yeah, so here you see also this funny names, Bruce and Chuck and FBI and whatnot, and you see color, chroma key, fog, alpha blend, disser, and yeah, then RGB mask, apply visibility. So yeah, this bit was missing, and now we found this, and now the Sunday is over. You see, producing low-level educational videos on YouTube is quite time-consuming, even, yeah. Of course, I have not done the Voodoo programming back in the day. It's the first time I do this. But even when we go further to not only the PS3 again in some days, but also Octane, very theoretically, I found some stuff for the Octane. So on Linux, there was never 3D acceleration for the Octane. There are 2 boards for the Octane. I have the Impact. Maybe another day I get the vPro, but different graphic options, and that will be the same time consuming, right? If we sit down with the Octane just for the love of SGI, MIPS stuff there, and YouTube education and fun and whatnot, it will also take a week or months to get this working. Same with the RSX, and this is why I do the videos to motivate people. You can do the same. You can, even if you're not in computer science and studied this, in my opinion, if each kid could get the specification and with just a couple of dollars invested, start here programming, And again, why do I do this with this? For the educational stuff, you see bits and programming and writing this to some registers, and getting started with this is of course much easier than for the NVIDIA cards where you don't have specification. And why do we have with this low? This is hilarious how bad the cable docks this is. 3511% frame drop even with 4.5 Mbit or something. Thank you very much. This amazing frame drop brought to you by Vodafone Cable DOCSIS cable crap. Anyway, I hope you enjoyed this journey here and documenting why do I make this video. Not only was I sitting here the last 3 hours finally getting Voodoo to draw more stuff, and also to document how to step by step do this stuff and how much work it really is, because some people always think, yeah, it's no work, stuff is somehow programmed by itself and whatnot. And yeah, you see this stuff here, of course it's first generation 3D graphic, so this stuff is still relatively simple, but I want for the Verge and Voodoo and certainly Rendition Verite, so for a couple of cards I want, well, the Voodoo cannot do more, right? The Voodoo and Verge, they can only do textured triangles, nothing else. And I think it's quite nice to have some example code to do exactly that. And that is what I want to have documented here. And then, of course, in another day, as soon as we have set buffer, depth buffer work, and text string set up, then we are more or less done. I could write a game, maybe some Star Wars kind of X-Wing stuff flying around there or something of that sort. Maybe even either a demo, I mean, first a demo, just some flying spaceship, something, and then maybe a little bit of shooting some spaceships if we are of course not tomorrow, I have some other stuff to do, but over the years here, over the next 12 months or something. And once we have this done here with the Verge and Voodoo, then of course we continue with the RSX and stuff. And the fun stuff is this kind of stuff when I travel soon to Moscow and stuff, when I have another evening, I can continue this with PC emulator. So even you, if you are in school or otherwise interested in this, young or old at home, to play along at home, you don't even need to auction this expensive on eBay. PC emulator can emulate the Voodoo card, and you can do this, my recurring theme here, to motivate people to do this kind of coding. In my opinion, much better time spent than sitting with Sudoku or Tetris, and just have some fun here with a PC emulator and writing some code and learn something and write a demo or game or something of that sort. And yeah, certainly RSX much more difficult, but there is hope to see the light at the end of that tunnel, because not only is it similar to the Novo existing direct rendering manager stuff, so we can reuse stuff, we just need to get it stably working, understand how the command ring works. And this is why I also do these videos, not only for my fun and education, also the, yeah, again, education of the broader audience here, that motivate people to really do drivers to either Linux, BSD, Haiku, get into this stuff. It's really not so difficult, even though, yes, sometimes even I have so many years of experience with Linux drivers and reverse engineering scanners. Yes, sometimes it requires 3 hours an afternoon to go through all the bits. And do I set this bit? Is this bit important? And maybe this bit, and eventually you win the lottery and find the bit. And yeah. Next, as I said, this fast buffer clears, depth buffer setting up, then experimenting. Right now I'm using the floating point interface that the Voodoo 1 doesn't have. I will most likely set up the example code here to use all the integer floating point and new style setup engine, and then text string demonstration, and then we are mostly done. That is maybe when I'm in Moscow with PC emulator, or the next time in autumn or something, because I try to keep the topic here changing, so 1 month a little bit more P3, and then also continuing with the other stuff that is not forgotten. I hope you enjoyed this and learned something, and the next time we go to the Voodoo, we will then have texture running. Thanks for watching, thanks for tuning in. I hope you enjoy this right here on the low level side, and would be amazing if you share, like and subscribe, give it a thumbs up, and I hope to see you soon for all the next programming and videos to come.